All right, welcome to the first of several videos on integral calculus, specifically looking at techniques of integration, beginning with the most basic of which is the power rule. So what is the power rule referring to? It's the integral of x to the n dx. We can consider cases where n is equal to -1 and where n is not equal to -1. Let's take a look at these separately. First, the majority of cases where n is not -1. So basically any number other than -1. In this case, the formula looks like the following here. We have n plus 1 as the new exponent. So you add 1 to the exponent and you divide by the same value. And include a constant of integration. In this case, I wrote c. In general, though, this constant will disappear when you find the derivative. This is why we have to include it. What if n equals -1? That leads to a very famous antiderivative. It's related to the logarithm, the natural logarithm. In this case, ln x plus c. We include an absolute value in general. Now, with this basic rule in mind, let's do 4 examples, and then in subsequent videos, we can escalate to more difficult situations. Here's our first example where we have a cubic. It's just the antiderivative or the integral of x to the 3 dx. According to the rule, you want to add 1 to the exponent and divide by the same number. So that would be x to the 4 over 4, and of course include a constant of integration. That's it. That's all you have to do. Now, do they get harder? Of course they get harder, but we'll deal with them slowly and steady. Here we go with another one. In this case, we have a constant in front, and then we have x to the 5. In this case, we can consider the 8 here as a spectator. So just put it on the side, and then we can deliver the antiderivative of that by adding 1 to the exponent and dividing by the same value. Of course, in this case, 8 and 6 reduce to 4/3, and you would have 4/3 x to the 6 plus c. Now you might say, well, how does the 8 just not participate? One of the rules of integrals says that you can always pull out a constant, and then you have a simpler question, so you can just focus on that inner problem there. This step here is optional, but it's nice to see it once in a while. Let's do one more example before moving on to the last example involving the negative exponent. So in this case, we just have another coefficient here of 4/3, and we can just think of the 4/3 as a spectator. So let's just write the 4/3 there, and then deal with the antiderivative of x squared, which of course is going to be adding 1 to the exponent and dividing by the same value. Don't forget your constant. In this case, we can simplify all of these numbers here by multiplying together the denominators to get 9. And then you will have your final answer of x cubed there, and of course the constant. Okay, one last example. I want to keep these videos short and sweet in the sense that we can be modular and you can flip through and quickly find what level you are in terms of your skills. So if you find this first video easy, you can maybe jump ahead in the future by a few videos so that you make your time most useful. In any case, let's go for this last one here with the negative exponent. And you see here a -1. Now, -1 was the special case involving the natural logarithm. So we'll have a 6, and then recall that 1 over x, or x to the -1, has an antiderivative of ln x. And don't forget your absolute value. And of course, a constant c. Now, I'm going to be writing the ln like that, ln. I'm writing it cursively because when I write ln like that, sometimes I think of that as a 1 if I'm in a hurry. So just keep that in mind. It's just a style thing. That's all I have for you for this first one. Let me know in the chat what you feel about this style of delivery. And if you like how it's going, I'll whip up a whole bunch of these videos and help you along your way. Thanks for watching.